Shape is called a quadratic function. The general form of a quadratic function is f of x equals ax squared plus bx plus c. That should look really familiar to you by this point. You can tell if an equation is quadratic if does it have to be an x squared? If there is a variable squared and we need to be a little bit more specific because there's lots of non-quadratic equations that have a squared in them. So yes, it has to be variable squared, but there's another important piece. Not that I'm thinking of. I'll give you an example. Is this quadratic? Has to be the highest power. I'll tell you in 1 second. So there is a variable squared as the highest power. These guys you'll meet next year. Anyone know what he's called? It's called a cubic. And then next year you'll meet crazy guys like this. Anyone want to guess? Can't be quadratic because we know that's with a squared. So quadratic, cubic. What are there 4 of in a dollar? It's called a quartic. And then you go up to the 5, which is called a... That would take me about an hour to explain. You can Google it and look it up. Well, we could, but then we wouldn't get through this stuff. What do we call it? What do we call them? There's 5 babies. Quint. It's called a quintic. So a quartic and a quintic. You'll meet them next year. Another name for a quadratic function is a parabola. That is not a parabola. That's a disease, I think, that's very, very fatal. It's called a parabola. I don't know. It just sounds like a disease. It's not parabola. It's parabola. Here's some fun facts about quadratic functions. Probably not so fun to you, but a parabola can have 2 directions. Until next year, when you find out I'm a big liar, because there's actually 4, but you don't need to know all 4. You only need to know 2 this year. Parabolas can point up or down. What's the 2 next year that we're not going to talk about this year? Left and right, but those are completely different equations, so we won't look at them now. It's where the y is squared, not the x is squared. A parabola can have how many x-intercepts? So take a look at this one. How many times does this cross the y-axis? How many times does this cross the y-axis? It can only have 1 y-intercept. It will never cross more than once. So if it's sitting right on the x-axis, it's still going to cross the y-axis once. Even if it's sitting above the x-axis, still going to cross the y-axis once. Even if it's below the x-axis, still going to only cross the y-axis once. And so what we're really doing is taking everything you learned about lines in grade 10 and just now bringing it to quadratic equations. So if we go back to lines, how many y-intercepts can a line have? So picture an equation of a line. It can have one, or it can have none. What kind of line would have no y-intercepts? You need two lines to be parallel. What kind of line? What do we call a line like this? Vertical. So you can have 0 or 1 y-intercept with a line. Our only choice is 1 for a quadratic function. But what about the x-intercepts? Well, this comes down to what we talked about with the discriminant. How many different possibilities do we have for the answers? Well, we can have no answers, or we could have one answer, or we could have two answers. You have a choice of 0, 1, or 2 x-intercepts. What about a line from last year? How many x-intercepts could it have? 1 or 0. What kind of line would have 0 x-intercepts? Horizontal line. You're going to get no x-intercepts when it's above the x-axis and it's pointing up, or if it's pointing down and it's below. So either one of these situations is going to give you no x-intercepts. What does that tell you about the discriminant? When you get one x-intercept or two equal roots, we talked about the discriminant, it's where it's sitting right on the x-axis. So it's not crossing through, it's just sitting on there. Or if it's pointing down, it's just touching right at the top. Either one of those situations is one x-intercept or one root or 1, 0 or one solution. And what do we know about the discriminant when there is one solution? Two is the most common, so if you think back to all the questions you practiced in Unit 3, mostly there's two solutions. If it's pointing up, it's because it crosses through the x-axis twice. And if it's pointing down, it does the same thing. And what do we know about the discriminant if there are two x-intercepts? Like I heard so tiny and quiet, greater than 0. You guys were all chatty when I walked in. What is in a purple can?
Oh, it's blackberry ginger ale.
Is that new?
Yeah.
Is it good?
Yes, it's amazing. I picked up 5 cases.
In the States or here? Excited.
I think it's limited time too.
All we're going to focus today is on the vocabulary, because obviously if you don't know that, you're not going to be able to do the rest of the unit. I'm just going to block off the first 4 words, because they're really the new words. The second 4 you've seen before. We're just going to talk about it in terms of parabolas. Not parabolas, no. The vertex is called the turning point of the graph. The turning point of the graph. And so if we look at this example, if I go from the left to the right, the parabola is going down, 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 down. Somewhere around here something happens and it starts going up, 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 up. That point where it turns, so approximately here, is called the vertex.
Would that also be the lowest y value?
Yes, we're going to get to that in a second. Grabbing my, well, it's pink, but I meant to grab red. This is always given as a coordinate pair, so you'll always have an x and a y value. So it's a particular point on the coordinate grid. Axis of symmetry. Well, let's talk first what's symmetry. You did that way back in grade 9 when you looked at shapes and you decided if they were symmetric or not. What does symmetric mean? Same if you cut it in half, so 2 equal sides. Well, all parabolas are going to be symmetric, so there's going to be a line somewhere. If we fold this in half, it's going to be exactly the same on both sides. Natasha? Yep, it's going to be a horizontal line right through the vertex. Now it's an imaginary line, so we always draw those with dotted or dashed because it's not really part of the graph. And if we folded our paper, which this is going to upset left brains to have a crease in their notes, but if we folded it right on that axis of symmetry, you should see that the two sides come right on top of each other. The definition in words, it's an imaginary line. An imaginary line that cuts the graph into two equal halves. Halves with a V or halves with a V? I be not your English teacher. Halves. I be not your English teacher. An imaginary line that cuts the graph into two equal parts. Now this is a line, so the answer is given as the equation of a line, so you got to think back to grade 10. You need to think about vertical lines specifically. Does anyone, like way back in their brain, remember the equation for a vertical line? So it's that y equals mx plus b stuff, except there's no slope. Well, there's so much slope that it's indefinite. Anyone remember? It's x equals a number. And I'll show you in a second where that number is going to come from, but it's not a coordinate point for axis symmetry. It's x equals a number because it's a vertical line. Minimum or maximum I put together because a parabola has one or the other. It doesn't have both. It either has what's called a max or a min. So it's either the highest or the lowest point of the graph. Highest or lowest point of the graph. And so the first thing you need to realize is that there's arrows on these lines even if we can't draw them on the computer. If it's just kind of going off into space, we assume it goes on forever. So this graph would not have a highest point because these are going up to infinity. It has a lowest point, and where is that lowest point? It's the vertex. So this is also called the max or the min. And I'm going to put both even though in this case I know it's a min. And you're probably like, well, that's stupid. Why are there different words if they're the exact same thing? Well, it's how we write the answer. So a minimum or a maximum is always y equals a number, not a coordinate pair like the vertex. I'll explain that when we get to the first example. The direction, there's a choice of two until next year when I loan to you. What are the two possible directions of a parabola? Up or down? What's a definition we could write down? Oh, I like the direction. Oh, we can't use direction to define direction. Something about the graph opening. What's a synonym for direction? The way. The way a graph opens. I like it. Now, keep in mind, I've told you a whole bunch of times mathematicians, right, words scare us. We tend to use symbols for stuff because it's easier. So the way we give a direction is we actually draw a little picture. This is how we would say that it opens up. Do you want to guess how we would show that it opens down? A little picture of a down parabola. We don't actually use the words, but you could write up or down if you like that better, but we actually just draw little pictures. So those are the four words that are unique to parabolas. The last four are just for graphs in general. You should have looked at domain, range, x and y intercepts when you did lines, so let's just bring those definitions back. Domain. You probably did a bajillion of them last year. Something with x, yep. Yeah, but it doesn't have to be between 2 points. I like that. We're on to something. Something with x, something with area. Yeah, XER, remember that notation from last year? Yeah, and there's the bracket thing. Yep, those are all coming back. It's all possible x values of a function. And we'll go over the notation when we do the first example because it's a little bit easier when we have actual numbers. What do you think range is then? Mm-hmm. Z. I show you. I got a program that does 3D graphing. It's pretty cool. So, left brains. This is how I remember which is which. What comes first alphabetically, domain or range? So domain comes before range alphabetically. What comes first, x or y? So x goes with domain, range goes with y. That's how I remember in my head. It's alphabetical. Y-intercepts, again, we just talked about them. You did them with lines, so they're not particular to parabolas. They're just for graphs in general. Definition of Y-intercept. Where the graph, I don't want to use the word intercept because we just kind of like have that in the middle, where the graph touches, crosses, cuts the y-axis. How many possible choices do we have with a parabola for y-intercept? It could cross once or none. Somebody going to fix that because we just talked about that on the other side of the page? It has to cross once. So this guy down here, right here, is the y-intercept. This one happens to be close to the vertex or the max min. It doesn't have to be. It just happens to be on this example. And if you think back to next year, or last year, you can't think back to next year. Last year, how did we give the answer for a y-intercept? So what do you know about the x value at a y-intercept? It's 0. So it's 0 and then whatever the particular value of y is, and I'll show you how to find that in a second. Definition of x-intercept. Possible choices for x-intercept. 0 or 1 or 2. This one happens to have 2. And how do we give the answer for an x-intercept? So look up what's up here with the y-intercept. It's going to be a number and then comma 0. Here's what we're doing for the rest of the day. Well, not the rest of the day, but the rest of the class. I'm going to give you the graph of a parabola, and all we're going to do is state those 8 vocabulary words. So we're going to figure out what is the vertex, where's the max min, what's the axis symmetry, what's the direction, the domain, range, x and y intercepts. That's all we have to do today is eventually get the graph, figure out what's going on over here. Tomorrow, we're going to do the same thing, but no graph. I'm just going to give you an equation, and then we're going to state the exact same 8 words. So we're just practicing the words today. What's the definition of a vertex? The turning point, and it's always given as a coordinate pair in x and a y value. So take a look at this graph. Where is the turning point of the graph? Where does it switch from going down to going up? 0, 5 is the first offer I heard. 0, -5 is the second offer I heard. Do we want to confirm either one of those? Which one? So 0, -5. Vertex is always given as a coordinate pair, x and y. Axis of symmetry is that line that cuts right through the vertex. It's imaginary, so we do it as a horizontal or a vertical dashed or dotted line. Because it's a line and because it's vertical, it always starts with x equal. Where do we get the number from? Where does x equal? Well, it comes from the x-coordinate of the vertex. So whatever the x-coordinate of the vertex is, that's also going to be the axis of symmetry. So in this case, x equals 0. The axis of symmetry in the vertex will always have the same x value. I always go to direction next because the direction determines the max-min, so it's the way it works in my brain. And the direction is either up or down, and we just draw a little picture. Is this one pointing up or is it pointing down? It's pointing up, so we just draw a little up parabola. No, you can put the word. Just words scare us. Well, first of all, we need to state if it's a max or min, then we need to get the value. I'm just going to grab my red pen. If the parabola is pointing up, it's always going to be a min, because we have a lowest value. If the parabola is pointing down, we're always going to have a max. That's why I like to do the direction first. So because this one is pointing up, I'm going to start by stating just min. That's all I need to write down. It's just showing me you understand it's a minimum value or a lowest value. It's always y equals a number. We just need to figure out where does that number come from. Well, it comes from the y value of the vertex. And so in this case, we have a min, and it's at y equals -5. So once you have the vertex, you also have the axis of symmetry, you also have the max-min, because they all come from that same coordinate point. Domain. Domain, you look to the left, and then you look to the right, and then you make some kind of conclusion. And there's two different ways to express the domain. You get to pick whichever one you want, but I'll show you both of them. So if we look to the left, let's pick, for example, 1, -1. If I go down, can I hit graph? Can I bump into the graph if I go straight down from -1? What if I went to 2? Am I going -2? Am I going to hit graph? What if I went to -3? What if I went to -4? I'm going to hit graph. -5, am I going to hit graph? -6, am I going to hit graph? Well, it's off the top here, but I will eventually hit graph. What if I went to -7? Well, what number am I going to run out of graph? Well, because of these arrows here, I'm never going to run out of graph. There's always going to be graph on the left-hand side. So what do we say the lowest possible value for the domain is? How far could I keep going? -infinity. Just keep that idea in your mind. Let's go to this side. If I go to +1, am I going to hit graph if I go vertically? +2, 3, 4, 5, 6. It's going to be slightly off, but if this kept going, am I going to hit graph? What about 10? What about 20? So what do I say the highest possible value of the graph is? So you have two choices to write domain I'm going to show you. The first one is called interval notation. Interval notation is where you start with the lowest value, which is -infinity. Ooh, that was a terrible infinity. And then the highest value, which is infinity. And then you use those brackets from last year. And so if the number is included, you use a square bracket. If it's excluded, you use a round bracket. Do you remember that, or am I talking completely a foreign language? Because some teachers don't teach set notation or interval notation. So if it's not included, which infinity isn't because it's not a number, you use round brackets. If the number was included, you'd use square brackets. The other one is called set notation. And set notation is where you give a statement saying the exact same thing that you set up here. So it's not an interval, you're just giving a statement. If x can be from -infinity all the way to infinity, what kind of numbers are those? Does that include whole numbers? Does it include integers, fractions, decimals, square roots, non-perfect square roots? So what do we call that number family that has all of those families in it? So I need to say something about the real numbers, but I don't want to use English because that's too many letters, so I'm going to use some notation. I'm going to start with x, And then what's the symbol in the middle I'm going to use? So it's like a C with a straight line. It's not an E, it's a Greek letter. Anyone know what Greek letter that is? It's epsilon. And what does it mean in Latin if I give you the letter epsilon? Is an element of. So what this is saying literally is x is an element of the real numbers. What it's saying in real English is x can be any single number. You can pick either one of these. I don't care how you give the answer. It's just you need to recognize both. So if a multiple choice example on the exam gave this, you need to understand that's the same as XER. James? Yes. I don't care which one you give. It's completely up to you, but you need to be able to recognize both. What was the domain for lines back in grade 10? Any kind of line except for horizontal, vertical, normal, slope kind of lines. What was the domain? So picture a line, right? Arrows on both ends. What's the domain going to be? XER. That never changed last year. And what was the range for lines? YER. That never changed last year. This is the one that's never going to change. So make yourself a note. This will be the domain for every single parabola until next year where I've lied to you. For this year, this will be the answer for the domain for every single parabola because they're always going to have arrows on the left and the right. It's like the free point. Just memorize it and spit it back even if you don't understand it. It's going to be the domain for every single parabola this year. I'm not sure what you're asking there. Yeah. We just solve the problem. We don't care what the domain is. That's applied. Did that answer your question? Hayden?
It says just for parabolas, so will we be doing objects other than parabolas?
Yes, in Unit 8. I'm going to choose XER. I don't know why. I just kind of like it better. You can use your negative infinity to infinity. It's completely up to you. The range, however, will change according to the parabola. So it's not necessarily YER. And it's because we have a lowest point or a highest point. So if the parabola points up, and you want to use interval notation, the range is always going to be whatever the max or min is. In that case, it's going to be a min. And it will be to infinity. And the min's going to have a square bracket, and the infinity's going to have a round bracket. Let's talk about why. Well, the lowest value has to be the minimum value. It's the lowest. The highest value is always going to be infinity because there's arrows pointing up. So if we think in terms of the y value, what we do is we look down and we look up. And when we look down, where do we run out a graph on this one? So is there still graph at -1, -2, -3, -4, -5? We're still okay, but what happens at -6? There's no graph left. So that's why the lowest always has to be the min. The highest also always has to be infinity. If you don't like the interval notation, you want to go to set notation. How we write that is x has to be greater than or equal to the min. Those say the exact same thing. One is interval notation, one is set notation. Now you can't mix and match. You can't use interval notation for the domain and flip over here into set theory. You've got to keep the exact same ones the same. So if up here you put your negative infinity to infinity, you're going to go with this top one, which for this one will be -5 to infinity. If you chose to put XER, you have to use the second notation. So in this case, the range would be x is greater than, not x, it's y, shoot, pretend that didn't happen. Y is greater than or equal to -5. You cannot mix and match. If you use negative infinity to infinity, you have to use round or square bracket, -5 infinity round bracket. If you use XER, you have to use this y is greater than or equal to. You cannot mix and match your domain and your range notation. If the parabola goes down, well, now we're not going to have a minimum value because the arrows are pointing down. Negative infinity is going to be our smallest value. What's our highest value going to be? The max. If you want to write that in set notation, it's going to be y is less than or equal to the max. So there's your little cheat box for range. Range. At first, it's like, what? The more you do, the easier it's going to become. Questions so far? Again, you can pick whichever notation you want, but you can't mix and match, so whatever you pick for domain, you have to keep the same for range, but you need to be able to recognize the other one. So if I give you a multiple choice with XER, you need to understand that's the same as negative infinity to infinity. X-intercept. Whew, these are the easiest because we pick them right off the graph. How many times does it cross the x-axis, and where does it cross the x-axis? As a y-intercept. Where does it cross the y-axis? So in this one also happens to be -5. Just watch that we give it as a coordinate pair where the first value is 0. Now the x-intercepts. How many times does it cross? There's one right here, and there's one right here. We usually go the smallest to the highest, but I don't care which one you put first. What's the smaller of the two? -3, 0. And then the second one is 3, 0. Let's just review. Vertex is a coordinate pair. Axis of symmetry is x equals, and the number comes right from the vertex. Max or min depends on the direction. If it's pointing up, it's a min. If it's down, it's a max. The value comes right from the y value of the vertex. The direction is evident. You look at the graph, it's either up or down. The domain will always be either XER or negative infinity to infinity, whichever one you like better. The range will match, and it comes from the direction. If it's pointing up, it's one of these. If it's down, it's one of those. The intercepts we pick right off the graph and just give them as coordinate pairs. Show me a thumb so far. Getting it, kind of getting it, not getting it. And I'm okay if you're here right now. Okay, let's do this one. Write down the vertex. Don't say it, just write it down. Turn and just compare with someone. If you had the same vertex, give them a high five. Like I heard no high fives, like not one. That makes me really, really nervous. High five yourself. What is the value of the vertex? I heard 0, 2. I heard 2, 3. 2, 3. 3, 2. I'm just writing down what you guys are saying. Can we come to a consensus here? Like my left brain's about to explode. How many units left or right? 2, and how many units up or down? Did we confirm 2, 3? Write down the axis of symmetry. Share and compare, high five. Like you're not even humoring me today, really? Now, if this is your answer, you are wrong, and you will not get the mark for that. When I look at that, I don't know, is that an axis of symmetry? Is that a max-min? Is that an y-intercept? Is that an x-intercept? When you just give me a number, I have no idea what it is. How do we state a y-axis symmetry so I know you're talking about an axis of symmetry? X equals 2. Okay? That tells me automatically, it's an x-axis of symmetry. Pick if it's a max or min, and then write down what that max or min is. Which one, max or min? Sometimes people will just circle if they get too lazy to write it down. I'm fine with that, but you need to first distinguish which it is. If you just have the value, it's not enough. So you're either writing the word max or you're circling the word max. What is the value of it? Y equals 3. Again, if you just put 3, I don't know what that means. Anything could be 3. Y equals 3 tells me it's a max or a min. Direction. Write down the direction. 50-50 shot. Really, I think a monkey could figure this one out. Domain is like the freebie point. Everyone should get the domain because I told you what it is and it's never, ever, ever going to change until now, sure. But for right now, it's not going to change. So x equals r, or the alternate is infinity to infinity. And I'm going to give both just in case you like one better than the other. The range. If you want to memorize this, go for it. I like to actually look at the graph and analyze it because that's going to make it easier when we get to some of the later units. And what I do is I look up and I look down for the range. And what I need to know is what's the lowest possible value and what's the highest possible value. So I look down first. What is the lowest possible value? So I just start looking at, okay, -4, am I going to bump into graph? -8, am I going to bump into graph? -12, am I going to bump into graph? Well, what do we know about these two lines down here? They're going to go on forever, so what is my lowest possible value going to be? It's got to be -infinity on the bottom. Then I go back to the origin, and now I look up. If I go up to 1, there's graph. 2, there's graph. 3, I'm right on the vertex. What's going to happen after 3? Nothing, so my highest value has to be 3. So what that tells me is the range is going from -3 to -infinity to 3 because it has to be lowest to highest. And now I just have to match. If I want my XER, what do I need to write here? If I like my -infinity to infinity, what am I writing here? -infinity, 3, the first bracket's going to be, and the second one's going to be square. Questions on how I did the range there? Okay, so I always look down first because I need the lowest, then I look up, and you're looking is where do you run out of graph, where is there no graph to find? Y-intercept, pick it right off the graph. We know it's going to be 0 something something. It does happen to be 0, 0. X-intercepts, how many are there? There's 2. We usually go left to right, but it doesn't matter. Well, if 0, 0's over here, what does it tell you over here? 0, 0. And the other one is 4, 0. Questions so far? I'm going to give you like a quick 5-minute review on how to graph. So if you've never seen this before, just relax. You can come see me later and I can go over it again. You can also email me. I can send you a video. I have the old operating system, so if you've got the new one, it will be a little bit easier. I bought the faceplate. And it went towards breast cancer, so it saved somebody's life. Makes me happy. So you go into your y equals, and if you've got, how about you turn it on? Then you go into your y equals. If you've got equations in there, just clear it out. So I always say clear out the crap that's in there. So you just go on to the y equals and hit clear. So if I had stuff, la la la, whatever, I just go and hit clear. Now, biggest mistake when you come up and say, my calculator is broken, I'm going to say check your plot. What that means is across the top, do you see plot 1, plot 2, plot 3? Those are just statistical, that was hard to say, statistical plots. And if any of them are black, you can't graph a stat plot and a function at the same time. So when I say check your plot, what I want to know are all of those black. Let's just say I check my plot and I see that. That tells me I'm going to have an error when I graph, so you have to make sure all your plots are white. So you just jump up to the plot, you hit enter to turn it off. Okay, so if you're like, my calculator's not working, I'm going to say to you, check your plot. And that's what I mean is go on the top, just make sure all of those are white. Let's just put in the basic parabola, which is x squared. So you've got a variable key right here, which is xt theta n. And you've got a squared button, which is x squared. Oh, xt theta n besides the alpha key? That's fine. Yeah, just new operating system, that's all. The variable key under mode left of alpha. Under mode left of alpha is called the variable key. You can also use the alphabet key. I just find it harder to get to the x than just using the alpha key. Everybody good so far? So once you've put in whatever equation you want, what you're going to want to do is go to graph. I want you to get that out of your head. Where I always want you to go next is zoom. And what zoom does is set up the axes so that we all have the exact same picture. And generally what you're going to pick is zoom standard. So when you did lines, it would have been zoom standard. Parabola would have been zoom standard. That's going to change a little bit later for us in Unit 6 when we're going to pick something different. For now, we're always going to pick zoom standard, which is number. So don't hit the arrow all the way down, just hit number 6. What zoom standard did, if you go into window, is you should have the exact same numbers as me right now. That's what zoom standard does, is set the axes from -10 to 10 from each direction. So it's similar just doing a little graph when you've got 10 units to the left, 10 to the right, 10 to the bottom, 10 up. There's no scaling involved. We've jumped by 1. And to go back, you just hit graph. Did anyone get a picture completely different from that? Or not get a picture at all? Or not get the axes? Or something really bizarre going on? What is the background picture that you have? I don't know. Let me play with it after. Questions so far? So you should have done this with the lines last year. If you didn't, that's what you missed. You need to be able to go in y equals, put it in a graph, hit zoom standard, and get this picture. We're going to graph the last example. So this one I've just given you the equation. So we have to first get the graph in order to look at it. So go back into your y equals, clear out the crap that you have in there. My paper just turned purple. It's kind of weird. Why is it purple? That's weird. It just turned purple. Oh, it could, oh. Oh, I still see purple. Can you see my screen okay? Can you read it? Okay, so I'm just going to start typing the equation, -2x squared. Watch that I've used the negative, not the subtract key. The negative is smaller and higher. The subtract is longer and further down. And then minus 6x. And then plus 20, and then don't do anything, just wait there. So the calculator is pretty good at picking out what your errors are. So I'm just going to go back, don't do this. And let's say that I use the wrong key, that I use subtract 2 instead of -2. And what's going to happen when I go through my zoom standards and I'm going to get this. And this is when you come to me in panic and you're like, my calculator is broken. And I'm like, well, go to, because the calculator is going to tell you what it thinks your error is. So if you ever get an error and you have go to as an option, pick go to, and the calculator flashes on what it thinks. So it's telling me right now something's wrong with that sign. It'll tell you if you're missing a bracket. It'll tell you if you're missing something. So pick go to, and the calculator is pretty smart. And so I'm now going to correct it, and I should be at the same spot as you. Go into zoom. What are we going to pick 99% of the time? Zoom standard. And the problem with this one is that does not give me a really good picture of the parabola. I'm missing that top chunk of it. And I need to know where the vertex is. So what do I do? So if you look back on the other side, it says right here. So if you pick your zoom standard and you can't see a good picture of the parabola, you're going to go into zoom. And it's off of your screen, so you can either scroll down or you can hit 0. 0 is zoom fit, and it's saying to the calculator, you pick what you think the window value should be. And the calculator's usually pretty good. Yeah, not bad. It's off the screen, so you either have to move all the way down or you just hit 0. So zoom standard sets at -10 to 10. Zoom fit is, hey, calculator, you pick. And if you hit your window button, you can see what the calculator has picked. The calculator left the x-axis alone from -10 to 10, but what did it do with the y-axis? Window. What did it do with the y-axis? It's going from -240 all the way up to 24.5. Okay? And that's how the calculator got this picture where we can see it really nicely. Questions so far?
Would the y-axis be our vertex?
We don't necessarily know if it's exactly on that point, so we're going to actually tomorrow's figure out how to find it exactly on the calculator. Yeah. Yeah, it's just the, that's fine. I'm just reviewing what you did in grade 10. Anything you're like, what is going on here? Let's just do a rough sketch of what this looks like. So I usually put my x-intercepts first, kind of sketch where the vertex is. Must use arrows. I get like a brand and just like brand your shoulder. Arrow. Forehead. Arrows. Questions so far on how we got this graph? Now, I need to know, last year with lines, did you do y and x intercepts on your calculator? So yes, because you had me, of course we did it. The other guys, have you done this stuff that we're getting into, like this right here, or is this like completely foreign to you? Okay. So I'm going to give you the value of the vertex. I'm going to show you how to do it in their calc, but you don't need to know this. I'll review this in 2 days from now because you've never seen this before. So I'm going to do it. Don't panic. You just need to know the value. So eventually we're going to go into second function calculate, and we're going to go to max. And then I'm going to ask the calculator, tell me what the maximum value is of this parabola. So the max value is negative 1.06 and 24.1. You can't even see that. Yes. Okay, so right now, I don't expect you to know how to do that. I'm going to cover that in a couple days. I just need to give you the value. No, I will give it to you at this point, not yet. Okay, so what's the vertex? Well, the calculator just told us that's what it is. And sometimes they're nasty decimals, and that's just the way it goes. How do I use that to get the axis of symmetry? X equals negative 1.06. I always do the direction next because I have the maximum depends on the directions when my brain works. That comes right from the graph. Is it pointing down or pointing up? Therefore, is it a max or a min? Julianne? Yeah. How do I state the answer? The domain? Or negative infinity to infinity? The range. Okay, again, you can memorize, or I like to actually look at the graph, so I look down and then I look up. What do the arrows pointing down mean? It's going to go to negative infinity. We know that right away because the arrow is pointing down. Where's our highest value? Where's the highest this graph goes, and then there's no more graph after that? It has to be the 24.1. So how do I state that if I'm using XER? Y is less than or equal to 24.1. If I'm using the negative infinity to infinity, negative infinity, comma, 24.1. The first bracket is, and the last one is square. I'm thinking you guys like the XER notation better, so that you keep blanking out when I ask for the other one. Y-intercept, I'll get it off the calc because, again, you won't know how to do this yet. Is 20. You'll learn how to do it in 2 days. I'm just doing it for you because I didn't know if you'd done it last year. Negative 5 and 0. Oh, thank you. Yes. Go Question, yes?
Does the y-intercept being like 0, 20, does that have anything to do with the 20 that's in the equation?
Yes. You're on to me 2 days from now. Sorry, 20 was the other one. For homework, if you flip, there's a sheet with Mickey on the corner, and that's why I put the characters so it's easier to find than that worksheet at the back. Question 1, 2, 3, you're doing the 8 vocabulary words for each of them. So it's a little confusing last year because I had the A, B, C before the question. So number 1, you're stating these 8 things. Number 2, stating the 8 things. Number 3. 4, all you need to do is it quadratic, yes or no? So that's all you're going to have is a yes or no for number 4. 5 to 8 are some explanation questions based on the vocabulary. Questions? We will correct this tomorrow in class. That means you have to have it done tomorrow in class. Oh, this takes 10 minutes, if that. If that. Always a good place to do math homework.